All right, hello everybody. So today we are going to start talking about some real world problems. In the last video that you watched in Chapter 5, Section 6, we learned how to graph linear inequalities, and that involved writing or drawing a line. Now, maybe that line is solid or dashed, and then shading on one side of the line or the other. So today I'm going to show you where that would be useful in a word problem. So this first word problem says Mrs. Shavak's 8th period class is going to the zoo. It says the class can spend up to 300 on admission. Write an inequality for this situation. And it says if there are 32 students and one adult for every 8 students, can the entire class and adults go to the zoo? So what we have to determine, first of all, is what the equation is going to be. And so when we go to write the equation here, we know that we are going to have 32 students times $8. And then in addition to that, so students are $8, adults are $10, but we have to figure out how many actual adults that we're going to have here. And so we have 32 students, and it says we need one adult for every 8 students. So if I take 32 and I divide it by 8, I end up getting 4. So that means we need to have 4 adults go. Well, if we have 4 adults go, and each adult ticket costs $10, it's going to be 4 times 10. And that total amount that we spend has to be less than or equal to 300. So we have 32 times 8 plus 4 times 10, and that number should be less than or equal to 300. If it is, that means the entire class with the proper number of chaperones can go. So the first thing we're going to do is we're going to do 32 times 8, and 32 times 8 is 256. And 4 times 10 is 40. And again, that still has to be less than or equal to 300. Now, 256 plus 40 is 296. And so what we can see is 296 is indeed less than or equal to 300. So since we got this is true, which means yes, the entire class can go. So that one wasn't too difficult because we really didn't write so much of an equation as more of a statement. We just wrote 32 times 8 plus 4 times 10, and then that had to be less than or equal to 300. Now, the next one that I'm going to show you is actually going to have you write a linear inequality like what we graphed in the previous video, and they're going to have you graph it this time. So it says Ben has $24 to spend on cookies and cupcakes. It says write and graph an inequality that represents what Ben can buy. Now, the first thing that we have to do for this type of problem is we need to define what our unknowns are. And the unknowns, let's call them X and Y just for simplicity's sake. And X is going to end up being the number of cookies. Oops. And then Y is going to be the number of cupcakes. So that's the first thing that is important to do whenever you are writing an equation that represents something in a real life situation. You should define your variables, and you will receive points for doing that. So in a problem such as this, what you just saw me do would be worth 2 points. Now, the next thing we need to do is to write the inequality that represents what Ben can buy. So it does say that he is capped at $24. So that means whatever he spends, which we'll write that part in a second, but whatever he spends has to be less than or equal to $24. So now we got to determine, how do you figure out how much he spends? Well, a cookie is $2. So if I would buy one cookie, it would be $2. If I bought two, it would be 4. If I bought three, it would be 6. So it would be 2 times X. So $2 times however many cookies that we buy. Now, in addition to that, so we're going to add, he wants to buy some cupcakes. We do not know how many, though, or how many he could afford, but we do know that they're $3 a piece. So we're going to have 2 times X plus 3 times Y. And so what you see right there, 2X plus 3Y is less than or equal to 24, is the linear inequality that we want to graph. Now, this is a little different than the ones that we did in the previous video, because this one is not in slope-intercept form. Now, we did a lot of studying and graphing earlier this year on how to graph something. Now, this would be in what we call standard form. And the way that we graph something in standard form is we take the equation, and we scribble out each of the x and y's and then solve it. So when I start out doing that, if I get rid of this whole 2x right there, what I end up with is 3y is less than or equal to 24. And so when I divide by 3, I get y is less than or equal to 8. Now, we're not going to pay so much attention to the less than or equal to right now, as we're just going to put a dot on the 8 on the y-axis. Remember, this is your y-axis, and this is your x-axis. Now, I'm going to do the same thing this time, but I'm going to get rid of the y. I'm going to get rid of that 3y right there. So I'm just going to have 2x is less than or equal to 24. And when I divide both sides by 2, I get x is less than or equal to 12. So I'm also going to put a solid dot on 12 right there. And now the next to the last step would be to draw a solid line. The reason why it's going to be solid is because it is less than or equal to. And I'm going to draw a solid line. Oh, that was a little bit off. I'm going to draw a solid line from that y value of 8 to the x value of 12, just like that. So now that we've got our line graphed, the last thing that we need to do is we need to determine which side of the line we should be shading on. Now, the way that we do that is we actually need to test a point. Okay, and the way that we test a point is we pick any point on one side of this line or the other, and we plug it into our inequality and see if it works. Well, the easiest way and the easiest point to always test, if you're able to test it, is going to be the point 0, 0. So this point right here, I want to test, because what will happen is, if this is truly in the shading, if it's meant to be shaded on this side, when I test that point 0, 0 in the inequality, I will get a true statement. So that's exactly what I'm going to do. I'm going to plug in the point 0, 0. So everywhere where you see an x and a y, I'm going to plug in a 0 and a 0. So I'm going to put a 0 right here, and I'm going to put a 0 right here. Now, what you're going to see is 2 times 0 is 0. That cancels. 3 times 0 is 0. That also cancels. So I'm simply left with 0 is less than or equal to 24. And what you see there is this is true. This is a true statement. 0 is less than or equal to 24. So because that statement was true, we tested this point 0, 0. We are going to shade on that side of the line. So all the shading would go over here. Now, had that point been false, we would need to shade on the opposite side of the line. And so now what you see is shaded is all of the possibilities of how many cookies and how many cupcakes that Ben could buy. So he could buy none. Yes, if you buy none of each, you're going to be below $24. But looking over here, there's an ordered pair. You can see this ordered pair right here, 2 and 2. If he bought 2 of each, he would be under the $24. He could go over here, and this point right there, that's 8, 2. So he could buy 8 cookies and 2 cupcakes and still be below the line. Now, the thing is, because this is a solid line, you would actually be allowed to pick points on that line as well. So this point right here, you can see 6, 4. 6, 4, since it's on the line, would also be allowed. So he could buy 6 cookies and 4 cupcakes, and that would be fine. So anything on the line or below will be an appropriate answer. Okay, so the last example I'm going to show you here today is it asks you to determine which ordered pairs are part of the solution set for the given inequality. And so the way we figure out whether it's a part of a solution set is you substitute it in. So you can see this is an X in an ordered pair, that's a Y. This is an X, this is a Y, that's an X, this is a Y. So each pair needs to be substituted in. And so I'm going to go ahead and do that. This first equation, I'm going to write it out. So it's 3 and then x plus 4y is less than 7. And I'm going to substitute this first ordered pair in, -2 and then +1. Now, as I follow PEMDAS and go down over this, 3 times -2 is -6. 4 times 1 is 4, and that's less than 7. -6 plus 4 is -2 is less than 7. And you can see -2 is less than 7. So this, I'm going to put a check mark beside it. That is true. So this point works. -2, 1. Now let's try the next point. We have 3 and then a 4 with the parentheses, and that needs to be less than 7. I'm going to put that one more time just for that last ordered pair that we're going to use is there. Okay, so we're going to put a 0 and we're going to put a 3 in right there. Now 3 times 0 is 0, so that one cancels. 4 times 3 is 12, and so we're left with 12 is less than 7. Now that is a false statement. That is false. So that means this 0, 3 is not a solution to the inequality because we got false. Now the last one, we're going to plug in -4 and -2. We're going to go ahead and simplify that using PEMDAS. So 3 times -4 is -12. 4 times -2 is -8. And so -12 minus 8 is -20, and that's less than 7. So that is true. -20 is smaller than 7. So this one also would be a solution to the inequality. So the one thing to realize about this, and I think maybe you hopefully gathered that from this example, is there are multiple correct solutions whenever you have a linear inequality because there's shading, and the shading encompasses multiple points. Any of the points in the shading will make that inequality true. So there you go, guys. I hope that made sense. As always, if you have any questions, feel free to email me. Have a great day.